So I'm going to be talking about construction and use of an ROV to detect water pH and O2 levels. And my name is Kevin Hong. I'm a student from Port Jefferson in New York, and my mentor was Soha. So the problem. Right now, pH levels have decreased by 30% since the Industrial Revolution. And if emissions continue, ocean acidity would increase by 150% by the year 2100 compared to pre-industrial levels. And this is due to the fact that CO2 and water combine to form carbonic acid, which produces H+ ions, decreasing the pH levels. And increasing acidity can affect reproduction, growth, and metabolism of marine organisms, as well as being harder for marine calcifying organisms to make shells, such as oysters, clams, and all those. And this dramatically alters the ecosystem. And on the other hand, oxygen content of the ocean has also declined by around 2% since the middle of the 20th century, and is predicted to decrease a further 3 to 4% by 2100. And this is also due to the rise in acidity of the ocean, because as the ocean becomes more acidic, it means that the water can retain less oxygen, which also is detrimental to marine life and can lead to dead zones, which means that completely dead, basically, and there's less inhabitable areas, less biodiversity, etc. All right, so how can we identify hazardous levels of pH and O2 levels through ROVs to better understand the changes happening to our oceans due to global warming? So first, we need to talk about ROVs. So what are ROVs? So ROVs are remotely operated vehicles, and they are unoccupied, highly maneuverable, and linked to the surface through a cord, allowing remote control. And by outfitting them with sensors, cameras, sampling devices, it allows for lifetime monitoring of the ocean. Furthermore, it can reach depths much deeper than the normal 40 meters that humans can, or else nitrogen starts to build up in your body and then just die, basically. And this allows us to gather information from the deep sea over an extended period of time. All right, so design and construction on my robot. So I constructed an 18 by 10 inch by 6 inch frame using PVC pipes and connectors, as you can see by these two pictures. And then I installed a 3-inch diameter housing in the middle, connected with 3D printed connectors. And as you can see, these are the 3D printed files, and those are what it came out to be. And I converted bilge pumps into motors by basically cutting them open, if you can see those, and then replacing basically this with the motors. And I coded and programmed the WASD keys to run the motors through an Arduino, which you can see down here. And I used a 300-meter Ethernet cable to connect the Arduino with a laptop to run the robot, which it took a bit of time. So, and then I attached a pH and O2 sensors onto the robot, which you can see down here, which allows basically monitoring, like lifetime monitoring of the oceans. And the total cost of this whole thing was about $150, which, I mean, it's pretty expensive. So, all right, so some challenges are waterproofing. So waterproofing the central tubing was a major challenge for me, as there were always like some holes or leaks in the central tubing that I had to cover up. And then once that fixed the first one, and then another one came up, so that took a while. Another problem was buoyancy, which was also a big problem because sometimes the robot would just tip over or be filled with water and then just sink to the bottom. So that was another challenge for me. And then the tether and power management was also a big challenge, because like having the tether connected to the robot and then supplying power to the tether, and then not making sure it's not like what's the word again, crumpled and mixed up together, was also a challenge. And the fourth challenge was the cost of the robot. All right, so here is a video of a test run. It's out of a pool, which sped up test run, which, sorry about the covering. So the results from this, are from the Port Jefferson Harbor, which is right down the street from me, and it's in the Long Island Sound, which is a part of the Atlantic Ocean. And as you can see, the pH levels in 2000 are much higher than the measured pH values that I got from my testing, which range from 8.08 to 8.05, which shows an increase in acidity since 2000, basically. And the measured O2 levels were also on the lower end of the healthy recommended O2 levels for a healthy body of water. And those ranged from 6.9 to 5.9 parts per million. So some takeaways from this is, even though the sample size is small, the results show that the pH value in the Port Jefferson Harbor was lower than it was 20 years ago, showing an increase in ocean acidity, which leads to deoxygenation, leading to less biodiversity, affecting the health of our ecosystem, leading to more dead zones. And yeah, and we see the importance of ROVs and environmental monitoring, as they can be fitted with sensors allowing remote access, long-term deployment, continuous and precise monitoring, and real-time monitoring of our world's oceans. And thanks for listening.
Thank you, Kevin. This is fascinating. A couple questions. So the first one is, you said that $150 is expensive, and I'm really curious what you were using as a point of comparison, because it doesn't seem that expensive.
Yeah, because
given the value of the results that you were able to gather.
Yeah, so that was without including like the cost of the camera, which was like made up a large portion of the money. And I already had that camera, so I just didn't include it. But $150, I mean, it isn't that expensive, but it also could have been less if I was more efficient, and if I had I can't formulate the words right now. It's like sorry. But yeah, it's not that bad, but it could have been better, because I saw some for like $80, you know.
I mean, it can always be better. That is the point of iteration in the work that we do. A question from the audience. So since the robot is remotely operated, is there capability to make the robot wirelessly controlled? And if not, how does the robot not get wet in short circuit due to the water?
So I looked into making it Bluetooth or like wirelessly connected, but that was very like inefficient, because water, it's hard to like send signals through the water, and that could lead to the robot getting lost, and without I can't, sorry, yeah, it could lead to like the robot not like working properly, I guess is how I would say it. And what was the other part of the question? Sorry.
Read it again. So since the robot is remotely operated, is there a capability to make the robot wirelessly controlled? And if not, how does the robot not get wet in short circuit due to the water?
Okay, so it doesn't get wet because I installed the central housing to fit all the electronics, and I make sure that was really waterproof. I used like Sikaflex to cover up the wires, like the wiring that goes inside the central hubbing, which made sure it couldn't get wet. And I also installed 2 of these like wax covered hubs, I guess we call them hubs, on either side to make sure it's extra secure, so nothing will get inside the tube.
Very cool. And then last question, just a question from the audience. What inspired you to focus on this area of research? Where did this idea come from?
So growing up, my dad and I always like fished, and I was also always like fascinated by the ocean. And I'm also like fascinated by robotics. So I decided to just combine the two, and then just make what I think was a pretty nicely built robot. So
As I said, it seems like a really cool blend of two passions that you have. So great work. This is really fascinating.